Okay, good morning, everyone. Thanks for attending this event. This is our first of a kind nuclear conference at HC Wainwright. Our first company we are meeting today is NANO Nuclear Energy, ticker symbol NNE. They're a nuclear technology solutions provider currently focused on Kronos, a micromodular reactor. And James and Matt will talk about it. They have a strong team, of course, starting with James Walker, who is the CEO of the company and a nuclear engineer. James, thanks for your time today. And Matt, I think you have to read some disclosures. You're the head of IR there, so please go ahead.
Appreciate it, Samir. Good morning, everyone. Before we begin, please just know that, forward-looking statements that are made by NANO management during this fireside chat regarding matters that may occur in the future are intended to be covered by the safe harbor provisions of applicable U.S. security laws. I encourage all listening to take a detailed read through NANO's safe harbor and forward-looking statements disclaimer in our latest SEC filings, which can be found on our website and the SEC's website. This disclaimer describes important risks and assumptions related to forward-looking statements, which may cause actual results to differ materially and adversely from results stated or implied by the forward-looking statements. You're advised that such disclaimer applies to statements made during our discussion today. I'll hand it back to you, Samir.
Thanks, Matt. So James, one of the things that we, Amit and I, we look at when we start to cover companies or look into companies is, of course, their technology and background and market. But we also look at the team. And I guess we can start with the team that you have, James, starting with you and maybe a few others that you would like to mention. We will get into the technology soon.
Okay, no problem at all. I think that's a good place to start. My background was as a nuclear physicist, nuclear engineer. I got my start on submarine reactors, the design of those for the submarine program. Reactor physics departments, thermal hydraulics, and I worked on that for a number of years before I got promoted out of that role into more senior management, where I managed core manufacturing facilities that would have a production line which would roll out reactor systems. And then I also was responsible for building a new fuel reclamation plant, as well as managing a few other nuclear facilities. I did that up until I moved to North America, where I carried on building industrial operations for industry and manufacturing operations. And through that network, I met Jay, who was the founder of the company. And we began NANO a number of years ago, initially concentrating on small microreactors and then obviously expanding from there. But we can get into that. Jay, I would like to mention as well. He was the first person in. I was the second. He had more of a capital markets background, but was very key because obviously when he said, "Can you build me a nuclear company?" I said, "Yes, but you've got to be very aware that this is a very capital-intensive industry with some very established players, and so we've got to have the right business structure, especially if we go public. We've got to structure it appropriately so we can build this, commensurately with where we need to progress to." So Jay was a very important aspect in the success of the company. Our chief technical officer, Florent Heider, he's a world-class physicist and engineer. He's been working with INL very recently, and he was the head of engineering at USNC as well. He was a very key person to snatch, almost our missing component, I think, in the team, because he's been able to very aggressively build up the company since we've recruited him, buying a big building in Chicago and staffing it with engineers. And also, who's been with us since the beginning has been Jason Garcher, our CFO. He's been very key. He had a lot of public market experience, and he'd worked with Jay on structuring a number of companies before. I think the components there of putting everyone in place was very important, but there's, of course, we've hired a lot of former NRC regulators, some very key military personnel, just to give us the contacts there. Former secretaries of energy have been part of NANO. We've had a couple now, Yeah, there's many key people, and our technical staff has grown quite substantially. We started with university and professors out of University of Berkeley and University of Cambridge, and we built teams around there. But since then, that technical team has expanded, massively to dozens of engineers that we've got located technical headquarters in Oak Ridge um, and now in Chicago area as well. So.
Yeah, no. So what I heard there was, yeah, go ahead, Amit.
Just on that point, before we move on, Samir, what's the competition for talent right now? Companies are coming up. Like, how are you managing that aspect of, your growth?
It's a very good point, actually. So there is a massive competition for talent at the moment. I think what's actually key in the recruitment of a lot of this talent is that the nuclear engineering world is kind of a small world, and everyone kind of knows each other. So it's certainly very beneficial to have people who are very well respected in the industry, because people will tend to trust the fact that high competent people have joined an organization as being the screening process for whether that organization is worth joining. So say, for instance, with Florent, like obviously world-class engineer, very well respected, people will join just because he's part of the company, as an example. Or Max, who is working on the Zeus reactor, or Eugene Schwagerhouse, who's working on the Odium reactor. Like so there is competition for it. Like even our chief technical officer, as soon as USNC went into Chapter 11, he was headhunted by everybody. And obviously he selected to work with us. We had what he believed was the winning technology, and it was sort of the winning technology that won him over. And then him joining us was responsible for, I think, 25 further engineers joining our company based on their belief that, this was an incredibly strong engineer who they had confidence in, that there was a job here for years because of his involvement and the fact that he'd screened us. So it is actually there's a big drive. Even the NRC, the federal regulator, has now lost all of its directors to private industry this year, just to give you an example of how everyone's poaching each other's people.
Yeah. Hey, James, this is as evidence that this is our first such conference. I did not introduce Amit and myself first. So
okay. No, go ahead.
So Amit Dayal is the senior clean tech analyst here. He has been doing this for over 20 years and has been with HC Wainwright and its prior incarnations all the time. So he has great depth of experience there. I'm Samir Joshi. I'm also a senior clean tech analyst, covering mainly nuclear companies. I have a background in nuclear engineering. I designed instrumentation and control systems for two 600 megawatt power plants based on pressurized heavy water reactors in India. So that's for us. That's about us. But James, what I heard in you saying is that you have fundamental research experience. You have operations experience, and with James, you have the capital markets experience. So you seem like a good, strong team. So really good to see that. So jumping into Kronos, just let's do that right away. What is the reason for choosing Kronos as the platform going forward? Can you talk up at a high level, and then we can get deeper?
Yep. So there's a very specific reasons, and obviously I could talk about Kronos all day, so I'll try and not do that. But Kronos is a very advanced reactor design, as in it's probably one of the most advanced designs in the entire country in terms of development. I mean, it's already had over $150 million invested into the R&D and development of that particular design. So it's very much de-risked, and it's a high temperature gas reactor too. And I say that in the context of it's already a known tech. It's already been in operation for many decades, and we've seen this work. So for an organization like the federal regulator, like the NRC, to license something like this is relatively straightforward because the data sets exist to validate the safety of the design. Now, if you do go for more novel technologies like I don't know, novel coolants or novel fuel types, novel like fast breeder reactors, things like that, you are going to have more difficulty proving the safety of it just because of the lack of those data sets. So it's one aspect of why it's important. The other main thing we liked about Kronos is that it's catering towards things like the emerging data center market and the massive power demand there. That's a huge potential market, and some of the power projections needed from the tech industry are astronomical, like dozens and dozens of gigawatts. And sometimes you think they don't understand what they're asking for, but they're essentially billions and billions of dollars in PPAs and power sales. The reason why the Kronos is very well suited to that is the fact that it's as large as you can possibly make a reactor before it stops being completely modular. And what I mean by that is that Kronos can be mass manufactured along a production line, and you could just churn them off and then ship them to site where they could be assembled like a Lego set. Now, as soon as you make a reactor bigger than Kronos, it is a small modular reactor technically, but it's no longer completely modular. You would still have to have a level of construction and fabrication at the site of certain vessels, like the reactor core vessel, as an example. That like our Kronos reactor core vessel is as large as you can make one and still just about transported by road, so you can keep that production line going. And that's important for driving down the capital cost of the implementation of a new reactor system. And then historically, the reason why you would get a very expensive nuclear project being built is that high upfront capital cost resulted in a very large financing cost being necessary. And often, say for instance, a big civil nuclear power plant, 70% of the entire project costs were actually financing costs. The actual construction and fuel and reactor system were a small percentage of the actual project. So this actually gives us a way to have economies of scale by mass producing reactor systems, having them being completely modular and not having to be subject to that situation where you have to have big on-site construction projects. And you're going to see that manifesting a little bit in when we start building our prototype reactors, because we're in a very nice position. We can build prototypes. We know it's going to work. It's a high temperature gas reactor. It's been done very much before. And it's a say for instance, a couple of other public companies, they're going to opt probably not to build a prototype reactor. They're going to get towards a licensed design, a sort of a licensed paper reactor, if you will. The difficulty there is that you might not get a lot of customers that will want to buy the first of its kind and be responsible for the building of the first of its kind. Whereas with ours, we'll be able to build this reactor, demonstrate it works, get it licensed while we're building it, output power, and then obviously demonstrate to everybody that like this functions very efficiently. We all know how to do it, and that'll de-risk our supply chains too. So we'll know exactly how to build it. We'll work out all the quirks in it, which we won't have to leave up to the customer to do. And we'll have all the necessary partners in place where we know we can get the components from so we can mass manufacture. But yeah, in summary, very known tech, very de-risked. I mean, we can't call it a TRL level 9 just because it's a slightly modified high temperature gas reactor, but there's high confidence. There's no way this reactor can't work just based on the historic precedents of operating high temperature gas reactor systems.
Right. It seems the technology is proven and you are operationalizing it or planning to. So James, just stepping back, just so that investors understand, what is going to be the form factor, the rating, and size of this reactor, and what are the targeted applications? Like what kind of customers are you targeting with this?
So, I mean, certainly with the Kronos reactor, one of the reasons we did really like this reactor when we went after it is that there was a major tech player. We can't name them just because I don't know if I'm allowed to, but they had done an assessment of every single reactor currently in the market. And Well, after they'd done that assessment and they spent 6 months doing due diligence, they had selected the Kronos reactor, our reactor system, to invest $500 million in. So the company prior to us, obviously they folded and we bought out that tech and we've continued to develop it. But they selected it for a number of reasons. One, they wanted to be able to co-locate with it. And they wanted this for the purposes of data centers. And so big projects, 800 megawatts, 900 megawatts, that kind of project. That's still the customer base we're targeting. But the co-location was very important. And what they quite liked is the Kronos reactor was able to be built in a series. So say, for instance, if you had 10 Kronos reactor systems, you could have sort of one adjacent plant that converted all of that heat into electricity. So you get economies of scale very quickly. Whereas if you ship one reactor system, you might pay a cost of 40 or 50 cents per kilowatt hour. But the reactor is never designed to be shipped one of its kind. As soon as you start getting into a number of reactors that have been deployed to the site, you drive down that quite substantially into single digit costs. So, 5, 6, 7, 8, cents per kilowatt hour. So that was a very important thing. So the customer base that we're targeting has already targeted this reactor, which is very nice. So as soon as we had this reactor, it didn't matter if it was Hyundai or Samsung or the big tech industries in the US, they were reaching out to us for this solution for their reactor. So in terms of form factor, if you can imagine a subterranean reactor system built into the ground, with just a small warehouse on the top. It's sort of a three and a half story deep reactor system, big reactor vessel, TRISO fuel, and TRISO fuel is very important for a lot of advanced nuclear companies because it basically makes the reactor an inherently safe system. And what I mean by that is that the worst accident scenarios that might be possible with a big civil nuclear power plant are just not possible with a TRISO-fueled reactor. You cannot get the same sort of meltdown that you could get at Fukushima or 3 Mile Island, which results from, say, a lack of pressure in the system or coolant leak that results in the fuel type overheating and then melting down. Because that can't happen, the normal exclusionary zone around a nuclear reactor is just eliminated. In fact, ironically, if you were to even fire a missile at a reactor that's fueled with our type of fuel, you would actually make the reactor less reactive. Like it would be because you would separate the critical mass by blowing it up essentially. But all the fuel would be containerized. So subterranean system, about 3 to 4 stories deep. TRISO fuel, which is what and the DOE spent billions of dollars qualifying that fuel to be utilized in reactor systems.
So it is a safe and modular design, and it can grow, I assume, as data centers may grow, and because you're co-locating and you can expand as you need. In terms of your development process, your relationship with the University of Illinois, Urbana-Champaign, how does that play into your strategy of going through the regulatory process and then eventual commercialization?
Yeah, it was very strategic. So, for instance, a number of companies are opting just not to build a prototype, and they're just going to advance straight through to licensing. But what we decided to do is that we could see that there are some companies already with a licensed reactor that never built a reactor. They just wanted to get a design license. The issue with that is that as a result of that strategic decision, they never got many orders in for that reactor type. So it was very clear that, if we wanted to build a long-term company, the credibility was needed to be earned by actually building out the reactor and proving it. So that puts you into a camp. Do you build it by yourself or do you build it with a partner? And the advantage of building it with a university is that you are subject to far fewer licensing fees as you construct the reactor type. So you make it a lot cheaper. Now, the downside of that is that if you construct that whole reactor system, you can't sell 100% of the power of that reactor. But we're much less concerned about that. The majority of the power we can still sell. It's really about a demonstration. And the first reactor that we will build at UIUC will be a lot more expensive than the subsequent reactors we build because it's undergoing a licensing process. Everything will be bespoke. So we're not looking to be as economic with that reactor system. It's to build it and get it licensed and demonstrate it works. And while we're doing that, we'll put all the necessary orders in place for the tech industry to do that. So I think that's sort of the key difference. And University of Illinois, they've got a high concentration of nuclear engineers. It was one of the first locations for reactors to be constructed, and they were obviously very supportive at state level too. So we've already been allocated the land where we can build this. The state's already signed off on it. The university has a number of personnel that they're going to be allocating towards this. I think the support was huge, and even the state has. We haven't announced it just yet, but they're working towards finalizing a lot of incentives for us just to facilitate, all the work that we're doing currently in the area, because it's not just the reactor system. Now we've obviously put a technical headquarters there, and we're going to staff that with upwards of 50 engineers. But the reduced licensing fees are very key.
Yeah.
Historically, and the NRC has come under attack, and they are in the past, and they are trying to reform. But long licensing times, expensive licensing times have been prohibitive in allowing new reactor types to get licensed and deployed out to industry. So.
Yeah, speaking of which, I think it was only last week or yesterday actually that they put out NRC put out a note saying that they're working collaboratively and they did mention reducing of the fees. So that's interesting. So just pivoting quickly to the Trump executive orders, which have made this possible. What aspects of those executive orders will be particularly helpful for you? If you talk briefly about that.
Well, there was a lot in there, really. Like the expediting of licensing times was a very key one. Under the Advance Act, under the Biden administration, they had reduced the maximum time of licensing a new reactor system to 25 months. The executive orders dropped that again to 18 months. That's very unprecedented. It does beg the question when the NRC might formally start the clock if they don't believe they can actually get it done in 18 months, because their MO is still safety, and their processes might still take longer than 18 months, no matter their will. But it's really the momentum in the industry. There's a lot of pressure on the regulator, and that pressure has come from many different locations. Like there's pressure from the DOE, there's pressure from the DoD, there's pressure from the tech industry. So that's one big one. The other one is as well is that they are making more available to industry the DOE Loans Program Office. Now this is going to be very key because the US is in a bit of a situation where it has probably the best reactor tech in the world, certainly advanced reactor tech. That will probably shape the entire industry in the future. But the issue the US faces now is that during the end of the Cold War, when the US and Russia developed its megatons to megawatts program, and they were decommissioning weapons, when Russia had all of that material available to it, it was selling it very cheap, and that killed the price of uranium, and it faster than government. And even some of the big established nuclear players, they can have a lot of inertia, and companies like ours can be much more flexible and move much more quickly. And the fact that we now have those resources available to us can give us ways to build capabilities necessary to provide us the materials that we can then utilize to build mass manufacture reactors, be involved in the fuel supply chain, and de-risk. So that was very key. And of course, there are things like tax incentives and tax credits and those kind of aspects to it too. But I would say, for me, I think the DOE Loans Program Office is the big one. That having access to that, and we've obviously met the chairman of the DOE Loans Program Office already, and communicated the things we'd like to build. And obviously, they're there to support. There's a pressure on them to support us. And I believe we'll utilize them very heavily in the future to build big national infrastructure projects that will advantage NANO, but actually it'll provide a way for everybody in the industry to benefit. That's ultimately what we would like to do too. So.
That's good. Thanks for that color, James. We are run out of time.
Oh, sorry. I ramble.
No, this is good information, and I think investors will really like your passion and your expertise that is going to help Nano succeed. Good luck, James. Thanks, Matt and James, for joining us today.
Okay. Thanks, Samir. Thanks, everyone.
Thanks, Samir. Thanks, Amit. Take care.